So let me ask you this, Bernie, and this is a very pregnant question among consciousness researchers, some of whom actually deny its importance. But is it possible to be conscious and not have some sort of a memory system?
Not if synapses are memory traces. Because basically what happens every night when you go to sleep, your cortex rewires. And if you're very young, or you've just gone through major life changes, it rewires quite a bit, and it may take multiple nights, perhaps, to make the adjustments. But essentially, you're growing synapses all the time. And this is kind of mind-boggling, because the most recent estimate I've read about the number of synapses is that it's about 250 quadrillion synapses.
And that brings up, it's like beating a dead horse for all my friends in the audience who have heard this comparison before, but my late dad was fond of a sort of a little factoid, not such a little factoid, that the notion of the number of connections in the central nervous system, in the brain. And he would say, well, look, if you want a good way to visualize the complexity and the numbers in terms of degree, you want to count the number of synapses 1 per second. How long would it take you to finish counting if you counted 1 synapse per second, if you're counting for the human brain? You would finish counting roughly 32 million years from now. So that gives you an idea of the immensity of this thing. I mean, arguably the most, or one of the most complex objects in the known universe, the human brain. But it's rather extraordinary, right? So that's pregnant with possibilities, right? Because for all those possible connections, there's a possible way or a myriad of different ways with which you can deal with the world, or you can map the world. Does that seem fair?
It does. And actually, I think there's evidence, very nice evidence right now, that using sensory feedback, you can actually learn to control single neurons in the temporal lobe. And of course, it's not just a single. What you basically do with this kind of study is you ask people who are having brain surgery, basically, but waking brain surgery, so all they have is basically local anesthesia to make sure that there's no pain. But they're fully awake, and they can carry on conversations and so on. It started with, mostly with Wells of Penfield, quite early on, 1920s and 30s. And so now you can pick out any neuron you like and land an electrode, just a tiny, tiny needle electrode, on the cell so you can pick up its activity. And then you can play back, let's say, an auditory click every time that cell fires. And under those conditions, quite quickly, you can learn to voluntarily control a single cell picked out at random from your temporal lobe, which has quite a few of those cells. How exactly that happens is not clear, but the phenomenon, I think, is well established by now. So this is one of the questions you can go home and solve if you like.
So, but good luck.